Okay, so in this tutorial we are going to go over constructing graphs involving time. We're not actually physically going to construct a graph in this video, we are just going to go through what the different types of graph might mean and how to answer different exam questions. So first of all, some notes to take down. Some different lines that you might come across when looking at distance time graphs. So a graph that kind of goes quite straight up like this could be considered a fast, steady speed. So we're going quite quickly and we're increasing at a steady speed. Okay. A line a bit like this one, just this diagonal here first. Okay. That could show a slow, steady speed. So you're going at a steady speed, but not quite as fast as the steeper line there. And then when it gets to this horizontal point, it's stationary, and that just means it's staying still. All right. So if something's flat on your distance time graph, it means they're not moving. A graph that shows a line a bit like this is showing where it's kind of started off fairly slow and then it's all of a sudden got faster and faster and then increased its speed dramatically. So in these three cases, sorry if you had to, I moved on quite quickly from that. So if you wanted to get those down in your notebooks, then go ahead and do so. Pause the video if necessary. Looking at three different types of graphs here, you might be asked to describe a graph. So this one, for example, shows you your distance and then your time on the horizontal axis. So your distance is on the vertical y-axis and your time is on the horizontal axis, on the x-axis. Usually that's the case. This type of graph here with a diagonal line going straight through the middle usually means that the distance and the time are directly proportional, which means you're going the same distance every minute or something like that. So in this case, they're going the same amount of kilometres every minute. In this graph, it's shown that it starts off quite slow, but then it starts to increase quickly. Okay, so the relationship increases. And with this one, you can see that it actually starts up here and it's slowing down. So this is going quickly up here and it starts to slow. An example of this first graph could be walking at a constant speed. So for example, travelling the same distance every minute, as I mentioned. An example for this graph would be an acceleration of a car. So as each second passes, it covers more distance. Okay, so steadily increasing, fast, 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 fast. And then this one is showing the relationship slowing down. So for example, a hot cup of tea will cool down quickly at the beginning and then more slowly as it starts to get to room temperature. So it won't go stone cold if your room is fairly warm, but it won't remain really hot either. Okay, so some questions to consider then in your exam. You sometimes get a distance time graph a bit like this. You can see the distance again on the y-axis, the vertical axis there, and the time across the x-axis, the horizontal. You can see that this time graph is only going from 10 a.m. to 12 noon, all right, with 11 in the middle. So we can actually work out that each of these 4 squares is an hour. Okay, so 4 squares is an hour, which means every 2 squares is half an hour, which means every 1 square is 15 minutes. Okay, so let's start by answering some questions then. What is the time of arrival at Bedford? So the time of arrival at Bedford is just to see, we need to just look for Bedford and we can see it's there. And we go along to the line on the graph and then we go down to the time section. And it's halfway between 10 and 11, so we can safely say that that is 10:30. Question B says the distance from Alford to Catford. Well, from Alford, which is here, where they begin, to Catford, which is where they end up, you're going all the way from that distance to that distance. If we look at the distance on the graph, it's halfway between 40 and 50, so we can safely say it's 45 kilometres. We know it's in kilometres because it tells us here. How long do they spend at Catford? Well, we can see here that they're not travelling. Okay, they're in Catford here, they've stopped. And they've stopped for 2 squares. We remember earlier we said each square is 15 minutes, so 2 squares must be 30 minutes. The average speed from Alford to Catford. From Alford to Catford, we know that they travelled 45 kilometres to get there. We also know that it took them an hour, because from 10 to 11, that is when they arrived in Catford. To work out an average speed, we need to do the distance divided by the time. They travelled 45 kilometres and they did it in an hour. Speed equals distance over time. So that's 45 kilometres divided by 1 hour. Your time must be in decimal format. 1 hour is a whole one, so we put a 1. So that's 45 kilometres per hour. Okay. What is the average speed on their return journey? On their return journey, they're coming from Catford back to Alford, which is still 45 kilometres, but they actually do it in only 2 squares time. 2 squares time is half an hour. So we need to do 45 divided by, which is distance divided by time. Okay, speed is distance divided by time. Their distance was 45 kilometres and they did it in half an hour. So you would use actually 0.5 there. Don't bother with the half. Let me write that down. Pen. Okay, divide it by 0.5 on your calculator or in your head, depending on what's being asked of you, which one it's in. Okay, basically 45 divided by a half. How many halves go into 45? That's 90, okay? Don't forget your time must be in decimal form. So it's half an hour, it's 0.5. If it's 15 minutes, okay, that's quarter of an hour, so it's 0.25. Be very careful. So your answer would be 90 kilometres per hour is their average speed. Okay, so let's go over this graph. So first of all, you've got another distance time graph, and this one's going from 8 o'clock to 11. That's 3 hours, okay? So 8 till 9 is 5 squares, okay? 60 divided by 5, 60 minutes, okay, is 12. So each square is 12 minutes, okay? So, I mean, we could write that down if you like to remind us. Each square is 12 minutes. Okay. So, the first question is saying, how long did they spend at Bigby? So, if we look for Bigby on our graph, and we go along to our line, we spent from here to here in Bigby. That's 3 squares. Each square was 12 minutes, so 3 times 12 is 36. So they spend 36 minutes in Bigby. It then says, how far is it from Bigby to Catby? So from Bigby, which is here, to Catby, which is there. Now be careful because you've already travelled 8 kilometres, so we only want to know what's left from 8 up to 20, which is 12. So it's 12 miles. Okay. The average speed from Airby to Bigby. So from Airby, which is just here, look, to Bigby, it took them an hour. They travelled 8 miles in an hour, and it looks like they're cycling. Okay, so they're not driving, so their speed will be slower. So their average speed is the distance, which is 8 miles, divided by time, which is 1 hour. 8 divided by 1 is 8 miles per hour. So on their bikes, they were travelling at 8 miles per hour. Okay. It then asks for the average speed from Bigby to Catby. So from Bigby, which is here, all the way to Catby, which is there. So obviously they've stayed here, so we don't want to count that line. They've kind of looked around and got off their bikes and stuff. So here they're now travelling again. So from 8 up to 20, we realised that was 12 miles. They travelled 12 miles, and it took them 2 squares to do that. Okay, so 2 squares is 24 minutes, isn't it? So distance is 12 divided by 24 minutes. Now 24 minutes is a decimal. Okay, to work that out, you would do 24 divided by 60 on your calculator or whatever, in your head, on paper, and it would give you 0.4 as a decimal. So you must do 12 divided by 0.4, not divided by 24 minutes, okay? It must be 24 written as a decimal, and 24 as a decimal of time is out of 60, so 24 divided by 60 is 0.4. And then finally we would do 12 divided by 0.4, and it would give you 30 miles per hour. Okay, and your last one, what is the average speed for the whole journey? Well, for the whole journey, here they travelled 8 kilometres, here they travelled 12, and then here they travelled 20. Okay, so 8 plus 12 is 20, obviously, and then 20 all the way back. So we know it's the same, obviously it's got to be the same distance, showing you. All right, so altogether they travelled 40 kilometres, miles, and they did it in a space of 3 hours in total. So 40 divided by 3 on your calculator would give you 13.3 miles per hour. So you could write 13.3, you can write it as 13 and a third, because the 0.3 is a third, isn't it? Miles per hour. Okay? Okay, so the last thing then that I just want to look at in terms of conversion graphs, it's not a distance time graph, it's just a conversion graph, is converting money. So this graph converts between pounds and Australian dollars. The first question asks you to change 20 Australian dollars to pounds. And a conversion chart will always have a diagonal line here with the two types of whatever it is. It might be money, it might be meters or kilometers or whatever. It could be converting inches to centimeters. It could be anything. But it will then have those down on the side on the axes. So here we've got Australian dollars on the y-axis, on the vertical axis, and pounds on the x-axis, on the horizontal axis, and our diagonal line going straight through the middle. To change 20 Australian dollars to pounds, you would go to 20 on your Australian dollars axis, and you would draw a line going to your diagonal. You would then go straight down to your pounds axis, and we can see there it looks approximately £8.90 or £9. So I'm going to put in £9. It then says to change £7 to Australian dollars. So this time we'd go to pounds on our axes at the bottom, and sorry, £7, going to 5, £7 on our pounds axis, up to our diagonal line and across here. So it looks like that would be about $15.50 or something like that, because in the middle there would be $17.50. So here it'd be about right. So, and they are looking for an approximate answer, don't panic. The final one says to change £400 to Australian dollars. So we don't know what £400 is. It doesn't tell us that on our grid anywhere. So we're going for pounds. So what I can do is do £10. £10 in Australian dollars looks to me like about $23 approximately. You could say $23.50 if you wanted. Okay? And what I'm going to do now is, because I know that that's £10, I can times that by 10 to give me £100. So £100 would be $230. And then I just need to times that by 4 because I need £400. So £400 in Australian dollars is $920. Okay? Okay, so another typical question that you could get in an exam in terms of graphs is this one. And it says here that each sentence in the table describes one of the graphs. Write the letter of the correct graph next to each sentence. The first one has been done for you. So the first one says that the temperature starts at 0 degrees and keeps rising, and it says that the answer is B. And as we've seen from previously in this tutorial, graphs like this are showing you a steady increasing speed, okay, and probably it's a steady increasing relationship, and the temperature is proportional to the time. So we can see there that that would probably be best to go with that first sentence. The temperature starts at 0 degrees and keeps rising. The second one says that the temperature stays the same for a time and then falls. So we could have a look at these and see which one we think. So we could say, okay, maybe this one, it stays the same. It doesn't really stay the same though. We can see that's increasing. Okay, so we can't use that one. This one increases, then stops or stays the same, and then increases again. This one looks quite good. Let's see. Yep, D. So this one says the temperature stays the same and then falls. Lovely. The next one says the temperature rises and then falls quickly. Now we can use one of our graphs where it rises. So make sure it's going to be one that's going upwards. So C looks quite good. It rises and then falls quickly, which to be fair looks about right. We can't really use any others. The next one says that the temperature is always the same. Well, if the temperature is always the same, or if something's not moving or changing, then it'll just be a straight line. So that one would be A. The next one says the temperature rises, stays the same for a time, and then falls. Okay, so let's look at these last two graphs here. This one rises, stays the same, and rises. This one rises, stays the same, and falls. So this one here, rises, stays the same, and falls, is F, which means this last one, the temperature rises, stays the same, and then rises again, is E. Okay, and for all of those, you got 3 marks, and they're pretty straightforward when you think about it. Okay, so really take your time on those. One last type of question that you could get in the exam is one like this, another distance time graph, but this time with 2 lines or 2 people. It says here that Robert left school at 3:30 p.m. and he walked home. On the way home, he stopped to talk to a friend. Okay, so if we look at Robert's line, okay, which is this one here. Okay, Robert left school at 3:30. He walked home, and on the way home, he stopped to talk to a friend, and then he carried on walking home. His sister Sarah left the same school, but at 3:45 p.m. over here. Okay, she cycled home using the same route as Robert, and you can see her line just going straight up there. Here are the distance time graphs for Robert's and Sarah's complete journeys. Question A says to find the distance that Robert walked during the first 10 minutes of his journey. So if we look at our time axis at the bottom, it's between 3:30, 3:40, 3:50 and then 4. So they're in 10-minute intervals. So it says find the distance that Robert walked during the first 10 minutes. So from here to here is the first 10 minutes. If we go up to his line, and it shows you that he travelled 1 kilometre. Question B says to find the total time that Robert stopped to talk to his friend. So we need to look for the straight line because that's where he stopped. And every 2 squares is 10 minutes. Well, that's only 1 square, so it must only have been 5 minutes. Finally, question C says to write down the distance that Robert had walked when Sarah cycled past him. So when Sarah cycles past, it's when the lines cross. So it's just there. And if we have a look over at the distance scale, it's 2 kilometres. Okay? And there you have it, your distance time tutorial. I hope that was really helpful, and I look forward to seeing you again.